Hello, everybody, and welcome to this presentation from James Murphy, who's the Display Technology Program Manager at GE Research. James is going to give us a presentation on the path towards enabling the next generation displays. As always, please do leave your questions in the sidebar and we will take those live at the end. Please leave them as soon as you think of them because there is often a slight delay. So it'd be great if we could get them, James, to answer them while he's still here. Thanks, everybody, and over to you, James, and I will reappear at the end. Thank you.
Okay, thank you very much. Yeah, my name is Jim Murphy, and I'm honored to speak on behalf of this talented group of scientists at GE Research in upstate New York. And today I'm going to speak to you about our market-leading wide color gamut narrowband phosphors and the path towards enabling next-generation displays. So whether it be for lighting or display products, the goal of the backlight is usually to generate white light through combining blue, green, and red luminescence. So the blue, of course, comes from the LED, while the green and the red emission come from phosphors. So when you mix a very particular ratio of green and red phosphor powders into a silicone and place that mixture on top of an LED, of course, you get white light. And phosphor-converted white light LEDs are where we make the bulk of our revenue in the display industry today. So today's talk is going to touch upon 4 areas. First, I'll provide a bit of background on the commercial success of our narrowband red-emitting KSF phosphor. Then I will present on the 3 areas in which our R&D team continues to innovate for next-generation displays. First, to complement our narrowband red-emitting KSF phosphor, we're developing narrowband green phosphors to enable higher color quality, wider color gamut on-chip phosphor solutions. Secondly, we're focusing on commercializing a new type, smaller type of KSF phosphor to meet the needs of the newly emerging 2D backlit market sector, which may contain mini LEDs. There are 3 architectures for small-sized KSF phosphor in this direct lit space: KSF on chip, KSF remote part, or KSF magenta LEDs. And last but not least, looking out more into the future, our 3rd area of development is in using KSF phosphor for micro-LED applications. So we've developed submicron and even nano-size KSF phosphor for micro-LED applications, inks, and photoresist that can be used to make films and even inkjet printed parts. There we go. So for those of you not familiar with KSF phosphor technology by GE, I'm showing some properties of the material here. The phosphor is called PFS, or KSF in Asia, because the composition is potassium fluorosilicate doped with manganese. PFS and KSF mean the same thing, and so for the remainder of this talk, I'll use the term KSF. KSF has 5 emission peaks, each of which is below 2 nanometers in full width half max. This line emission centered at 631 is what enables wide color gamut displays. A license is required by GE to use KSF phosphor in the display industry, and we partner with Current Lighting Solutions for phosphor manufacturing. There are now more than 40 billion KSF containing LEDs sold into the display industry. We have 19 licensees in 6 countries, and we're very proud that we've penetrated all 4 major display sectors, as I'll show you on the next slide. So unlike other competing technologies, the excellent performance, robust nature, and cost-effectiveness of using KSF phosphor has resulted in our technology being the wide color gamut red-emitting material of choice in all 4 major display sectors. You can find KSF in smartphones, including the new ultra-rugged phones for first responders. KSF is doing exceptionally well in monitors and laptops, as KSF is most often chosen when battery life, energy efficiency, and color quality matter. Here we show KSF in the 2020 SID Display of the Year, which is a 2D backlit monitor, as well as a new Dell gaming laptop that has a 300 Hz refresh rate. It's in the iPad and the Samsung tablets, as well as several other tablets. And it can be found in TVs by several companies, including 4K HDR full array